All right, so for question number 7, rotational motion, let's get the speed. And by the way, we needed a moment of inertia for this one, which I gave you, which is I is 2/5 mr squared for a sphere like this. Let's get the angular speed of the descent of the wheel as it slides down the roof. So this height here is going to be L sine theta if we use our trig. So let's use conservation of energy, mg h equals 1/2 mv squared plus 1/2 I omega squared. So we're going to say mg L sine theta plus 1/2 mv squared, equals 1/2 mv squared plus 1/2. Now here we're going to put in 2/5 ml squared, and since we roll without slipping, this is going to be over r squared, be v over r squared. Sorry, this is 2/5 mr squared. This should cancel. Now these cancel, and so what we're going to end up getting is mg L sine theta equals 1/2 mv squared plus 1/5 mv squared. And when we actually simplify this, this is mg L sine theta equals, so 1/2 plus 1/5 ends up being 7/10 mv squared. The m's cancel, and so right as we leave the ramp, or right as we leave this roof, we're going to have v equals 10/7 gl sine theta, all under a square root. So that's a. Now we want to know its horizontal speed. We want to know where from the edge it hits the ground. So let's be clear here. We've got a little bit of a problem, which is that we leave the roof like this. So we've got an angle theta here, so we have a v initial y and a v initial x. So v initial x is going to be square root of 10/7 gl sine theta times the cosine of theta. And v initial y is going to be this same quantity times the sine of theta. So let's get the time it takes to hit the ground. So we can say here, I would say v squared equals v naught squared plus 2g, and we have this height h here. And let's get the v at the bottom. So this is going to be v equals the square root, well, let's just be clear. So v squared equals 10/7 gl sine cubed theta plus h times 2g, because that's the v naught squared. That's sine cubed. And so to get the time it takes to hit the ground, the v when we hit the ground in the y direction is 10/7 gl sine cubed theta plus 2gh. And so this is v naught y, this is vy, this is v in the x direction here. So to get the time, I'll kind of outline a solution here. We're going to need vy equals negative gt plus v naught y. You'll need to get t, and then you'll need to use that to get x, using x equals v naught x times the t that you had before. So I'm happy to check that for you, but I want you to finish this problem on your own. That's the first torque problem.